Welcome to this talk on the kind of some news on the REST frontend, and more particularly on the REST frontend post libcore. So to begin, we will cover a few recent news about reception expectations, because recently REST has been moving in some areas, like for example Git. Git tries to integrate REST in their code base, and it brought some questions and some expectations, and it brought a lot of problems, and we try to go everything we've heard along those lines. So we've discovered that there is way more people than expected that are willing to have a REST frontend within GCC. Usually, the profile of those people are Clang or GCC regulars that may need a little bit of motivation to take the plunge to learn a new language. And some people want REST in their code base or at their company, but they're already using a GCC toolchain, and they basically don't want to change their whole toolchain, their whole process. So a REST compiler within GCC would help them greatly. And more compiler may bring more confidence to adopt that new language. And finally, there's a question about architecture support. Basically, Rust-C, the current official Rust compiler, doesn't support as many architectures as GCC does. So this brings some problems for some people at Debian, which are looking to support some package for some old architectures such as Alpha, HPPA, Motorola 68K, or even SuperH. Just a slight detail about M68. Clang and LLVM does support M60K, but it only supports the 16-bit alignment on Linux. We've also got some problems with macOS property with Rust-C, and I've put a link to the platform grid and platform support for Rust-C in case anyone want to check what they're supporting and at what point are they supporting the architecture or target triplets. So there is another project which you may know, Rust-C Codegen GCC. And I found that not many people are willing to use Rust-C Codegen GCC. I have not yet identified why it is so, but it may be because it is harder to integrate, and it is not the default option. I mean, you've got to use the Rust compiler, so you need the Clang and LLVM ecosystem, and you need to switch actively the backend to Rust-C Codegen GCC. So yeah. And also, the other problem might be the lack of support for architecture in the standard curl library. Basically, if you can compile some code, but you don't have any support in the standard library for the types or type size or anything, well, you won't go very far. And GCCRS might bring enough attention to those points to start some support in the standard library for missing architectures. Okay, now we'll get to recent progress in frontend. This one is kind of old, because if you remember correctly, last code one, I already talked about the name resolution, and how the old name resolution could not handle some situations by design. Basically, the old name resolution was one pass, and thus could not name resolve some identifiers after macro expansion and such. So yeah, just as a reminder, the name resolution in Rust is very complicated, and you need to first get all your top-level items, and then you name resolve some other items like your path, and then you need to do macro expansion, check that nothing has changed, or if anything has changed, you need to go back to the beginning and name resolve everything that has been expanded until all macros have been expanded. And then at the later steps, you've got the late name resolution, which really handles the rest of the identifier to resolve, like, let's say, variables and such. So over the past few years, we've been working on this new name resolution. Initially, it was deemed to be a simple project. Like, I usually quote Archer. At the beginning, he said like it would take like, let's do this. It would take at most 3 weeks. A few years later, it did not, in fact, take 3 weeks. And so yeah, we reworked the rule name resolution from scratch. And we wrote some tests exclusively for new name resolution because we knew those tests were incompatible with the old one. We duplicated, we kind of duplicated the existing test for name resolution, and we would run both the old name resolution and the new name resolution on all those tests to keep track of the gap between both. And yeah. The name resolution was kept enabled. The first name resolution was kept enabled for while the development of the new name resolution was ongoing, to avoid any hindering on the old pattern compiler. I mean, we cannot just break that whole pattern compiler and prevent our people that are working on other paths to just stop their work. So good news, name resolution 2.0 is complete. And by complete, I mean we reached feature parity with the old name resolution. And in fact, it was already the case when we began this new name resolution, but we handled even more cases with this new algorithm. So we enabled it by default on July 3rd, and the test cases have been deduplicated because we're in the process of removing the old algorithm. It is not yet finished. We're nearly there, but there are still some rough edge cases that need some handling and some special handling, special cases that need to be fixed. Recently, we've changed our methodology. We used to work in parallel on GCRS with some people would just take some random snippets from Rust that they knew worked with Rust C, and they would just gather it, reduce it, identify what wasn't working with GCRS, and fix the compiler, add a test, and repeat ad vitam aeternam. So this is not the case anymore because during the past few years, we've chosen to focus on the core library. So our workflow was, for the past year, try to compile libcore, and obviously it doesn't work because the compiler is incomplete. So you hit a problem. So you report the problem, you report the issue on the repository, you remove the problematic parts, and you try to work around it. And yeah, you begin again, you try to find a problem, report it, and again, and you try to fix the identified issues. It's great because a lot of contributors can work at the same time on that goal, on the libcore goal. But recently, sorry, I'm going a little fast. Recently, we had changed. Sorry. This was great because it helped identify high priority issues. We had better overview of the project. I mean, sometime with the old method, we would just take some snippets that weren't really used. There were, let's say, some edge cases, and yeah, those edge cases are important to fix, but are not directly important for a project. I mean, not directly used within, let's say, REST for Linux or within core library. So they had lower priority. So yeah, and recently we hit another problem. It is a libcore bottleneck. So with that new workflow, we all focus on libcore, but recently there was a lack of problem, to say it, on libcore, because we fixed so much thing on libcore that there's not enough problem for every engineers to cover. So we each problems in a serial way. Like we need to fix the previous problem to discover the next one. And in one way, it is kind of great because it really means we're nearly at the end of this full goal. But yeah, it kind of is inefficient. So for now, there are a few engineers working on really focusing on libcore, trying to fix things iteratively in that serial way, and the other people are working on all issues that are not directly tied to libcore or yeah, not directly tied to the actual files from libcore. Okay, so among the past few improvements, we've got the const generics and const expressions. We chose a few years ago that we would target REST version 1.49 because it was the last release before the introduction of const generics. The problem is we need to support const generics for libcore because libcore on the standard library acts like a nursery for REST code. So the doc feeds their own nightly features to ensure those features can be stabilized and can be used in different way before releasing and stabilizing those nightly features. And we need to stabilize, we need to support const generics and const expressions. So I've put an example about what we currently support. That work was done by Philip in previous year. We now support const generics over arrays as well as some const functions to process, let's say, the size of at compile time of an array. Yeah. Another improvement was the bit position implement traits. So there's two kinds of bits, and for non-Rust developers, it allows the usage of traits as interfaces. You don't basically you could use traits with generics, but import traits allow you to use those traits as interfaces without prior knowledge of generics. Let's see an example. So as I said, there's two kinds of bits. Right now, the argument position import traits, it is roughly equivalent to a generic parameter. So I've put some code below. Those two functions are nearly the same. And so the T generic argument as the call traits, and over the execute A bits, you can see that this over syntax is nearly just some sugar over the first function. The actual type is implicit and it is inaccessible. So once you're in the body of the function, you cannot technically know what type is used for the generic, but the compiler knows it. And that's not the case with the first function. Second kind of bit is the return position import traits. This one is a bit tricky because it doesn't work in the same way. It is not a generic. In fact, the compiler needs to create a unique opaque type, and this it is opaque at the language level. Obviously, the compiler knows which type it is. I mean, otherwise it wouldn't work. It wouldn't be able to work with that type. And that type is inferred from function body. It has nearly the same purpose as APIT, but it is used for return type. So let's say, for example, you want to return some type, and you do not want to leak which type to the caller or your function. You could just return that interface. The compiler will handle everything for you, and only the interface from the traits can be used by your caller. This year we had some GSOC students once again. There was 2 projects. The first one was about pattern matching. We had some pattern matching, but not all kind of patterns were handled correctly. So there was some work that was needed. And Diheng, our first student, worked on basically he tried to rework our patterns, how we are dealing with them, and he implemented a lot of REST pattern. So I've put an example of a REST pattern right here. So you can see the 2 dots over here. That's a REST pattern. It's basically to say, let's match over some part of structure. It could be a tuple, a struct, or an array. And just let's not care about the rest of the structure. So here I put a tuple, but yeah, it basically works the same with, let's say, structure, where you would like to get only the first few fields, or an array where you would get either the first few and last field, first few fields, or last fields. Some patterns are still missing. So I've put a pattern here that is still not handled by GCRS. You can see it here. So basically, we're trying to match the X binder to the value inside the A structure. The second GSOC student has been working on lints. So basically, our all lints implementation relied on the generic structure within GCC. So we were missing some information with actual generics, because we had some type erasure, we had some some information were missing. So we decided to move all existing lints from Gimple back to HIR, and it allows, for example, to have more information and analyze generics and traits and on functions before they are instantiated. So all lints were post-monomorphization, and the new lints are working on the right before the monomorphization. So yeah, that's right. There are still some missing bits. For example, we still miss some lints with some unusual assignments, as well as some support for linked attributes. Let's say you've got some attributes which say, please do not emit a warning over a few next statements. This is not supported yet. We brought a small problem at the last column, where we were a bit worried because we found some problems. For example, a file that was very macro-heavy dependent was, let's say, 1,000 line of code would compile in almost 30 seconds. That's not a real benchmark. I mean, that's just some crappy and easy time measurements with time. So that's more to give a rough idea of how bad it was. So it is not a priority because, I mean, we would optimize a compiler if the compiler isn't finished yet. It makes no sense. But we still looked at our code to detect whether there was some problems, or if our implementation was just slow. And we found some problems in the type checking. The type checking was doing a lot of unnecessary copies. We're talking about some combinatorial explosion. So basically, some types were copied over and over more for, let's say, 3 or 4 yes. Let's say 5 lines of code, you would get like 65,000 copy of the same types. And yeah, obviously that was low. And now we are doing a lot better. Yes. Next steps. Over the few next month, we will work on some features. And I'm talking about features and not bug fixing. We will still have a lot of bug to fix, but the features we are expecting over the next few months are the drop traits. So for those of you who are not familiar with drop traits, it acts like a destructor. It can be called either manually or automatically. And we need to handle where to put those drop calls automatically within the code at the end of each scope, as well as the glue to recursively drop structures. Basically, if you got a structure which has some different fields, and each of those fields implement drops, you need to drop all those things in recursively. Another thing that should be implemented is the drop check. Basically, in Rust, the drop traits rely on the borrow checker, because the borrow checker must ensure that all references to some value are done, dead, let's say just dead, before dropping value. And so there's some easy rules that should be implemented, like drop check, which check whether all generics from a structure are dropped before that, are dropped after the structure. And there's something in the libcore that also needs some support within drop check. That's drop check type patch, because sometimes the borrow checker relies on the function signature to ensure that all references are dropped, but sometimes it's not enough. Basically, the Rust project has tried to keep things trivial and as easy as possible. And for now, they just rely on the function signature. But in future, they might rely on the function body. So the drop check patch must be implemented to be able to tell the compiler, let's just forget about that. We know it's unsafe, but we know, because we as a programmer can see the body of the function, and we know that a reference won't be used. So so that thing could be dropped safely. Another feature is the FN trait. That's trait used by Clojure. I've put the definition over here. It is partially implemented, but there are still some problems around it, and Philip's out to work on this. Same thing with gene trait handling. Gene traits is required to support the dynamics of dispatch when you go to the table, and it is almost complete, but there are some rough edges, and we need to support them. Okay. Let's talk about post-libcore. I've had a lot of questions about when will the Rust compiler be ready, and yeah. So we're aiming at compiling, and by compiling I mean only accepting. Please wait a bit, David.
What does ready mean?
Sorry?
What does ready mean?
Yes, I was going to say about it. By ready, we mean accepting the code from the core library. We do not mean actually compiling it correctly. By the end of the year, we think we will be able to have the libcore accepted by compiler, but there will be some additional work required to ensure that everything is compiled correctly and that's not utter garbage that is thrown by compiler in the assembly output. So yeah. Our next stops will be Rust for Linux. We will begin over the next few months to implement some nightly. Let's switch the slide. Yeah. We'll begin to add some nightly features that will be available behind some hidden flags. Basically, our main goal is Rust for Linux, and Rust for Linux requires some very modern features that were introduced very recently. And we don't want to bump over every iteration of the standard library, over every version of Rust, just to support Rust for Linux. So we'll introduce some features behind some flags just for Rust for Linux in order to compile Rust for Linux correctly. Yes, right after that. Okay. Next step would be obviously standard library, version 1.49. We don't want to change the version now because, it will bring a lot of changes, and let's get it simple and correct first. We won't get there for free, but most of the features should be there because libcore and the standard library share a lot of common features, so it shouldn't be too long. I don't want to give any deadline or any date or anything, but yeah, it should come pretty quickly. I've had some question about the GCC bootstrap. Basically, in GCC, we introduced last year a dependency to rustc and cargo, and everyone disliked that, and we dislike that too, and we would like to remove that. But we've got some Rust components to compile. If we want to compile those Rust components, we need to compile their dependencies, and their dependencies are obviously the standard library as well as the core library, because the standard library relies on the core library. And when the standard library version 1.49 will be complete, we'll be able to compile our own components. So this means that at this time, we'll be able to compile in a first stage an incomplete Rust compiler, which will be then able to compile its own Rust components, and then there will be a final stage where those Rust components, as well as the basal compiler, will be merged together to be a complete compiler, able to compile valid Rust code and reject valid Rust code. Because if you remember correctly, or maybe you don't, but that's fine, among our Rust components, we've got Polonius, which is the borrow checker. So this means that our let's not say the first stage because it may just confuse everyone. The incomplete Rust compiler won't be able to do borrow checking, but that's fine because our Rust components have been compiled with rustc, and we can borrow check with rustc whether it is correct. So even if we just need it to compile and lower to assembly the Rust code. And yeah, that's just for the bootstrap stage. And obviously, this will allow the removal of the dependencies to rustc and cargo, and everyone should be happy. Well. Next step in our journey within the Rust frontend will be the standard library 1.80 plus. Let's just say any recent standard library. We want to evolve, obviously, toward a newer Rust version. Most of the crates in the Rust ecosystem are written in very recent version of Rust. So that means that if people want to be able to use GCC with their favorite crates, we need to support those versions. And it shouldn't take as many time as what we already covered. I mean, we already implemented a lot of things, and the language itself doesn't have many changes between REST version 1.49 and 1.80. I've put trees there. There's a trait upcasting, the use syntax, and the RPITIT. Just to see if anyone has followed correctly, what does RP? Can anyone make a guess about RPYTIT? No, that's fine. Return position implementation impl trait, so the same letters we've seen earlier, in traits. So yeah. Over the few versions between 1.49 and 1.80, there's a lot of features that were in nightly, so we already had to install them within our compiler because those are used within libcore. So yeah, it will be only a matter of stabilizing them, and that's it. So most of the work has already been done. Okay, upstream synchronization. Let's talk about our process. Yeah. One comment that has been done on GCC is the upstreaming process. Basically, it was we're not seeing you enough during the year. We're seeing you right before the freeze in November, and that's not great. And we agree with that. So we said last year that we would upstream every 2 weeks. And as you can see on the slide, there's not 2 weeks between January and March. There's little more than that. So we kind of failed on the objective. But we've improved our process to automatically handle some part of the upstreaming process, and now it will be a little easier. I cannot guarantee a 2-week window for upstreaming, but we'll try to get it a lot shorter. You'll note that July is has been strike through because we were ready to upstream some patches, but there was some little misunderstanding with the release manager, so we did not upstream even though we could. So yeah. Okay, second point is the synchronization. Basically, last year and over the past few years, synchronization was really a painstaking process because we would accumulate a lot of commits from the upstream repository, and we would get widely desynchronized, and that it means that we had to handle thousands of commits. It took a lot of time for contributors to synchronize those commits upstream back in our downstream repository. So yeah, so we introduced some new workflow and tools to do that frequently. And before, that was a manual process, and now that it's been kind of automated, and it is now done by Mark over there. It is done every month, but it could easily be done every week, so that's great. We won't have any big discrepancies between the changes upstream and the changes downstream. Yeah. So, another point. When you've got two repositories, I mean GCC upstream and some GitHub downstream, there's a third point that matters, it's a patch review. Basically, you need to send some patches for review before pushing some changes. And it was very it was wrong. It was simply plainly wrong, because we would send, let's say, batches of 200 commits at a time, and nobody would read the patches, nobody would review them, and I mean, nobody would like to review 200 patches from a front end they don't even know that well. So there was too many patches, and sent in unrelated batches at irregular time. Nobody could expect when patches would arrive in the upstream. So yeah, nobody would review them, and not even the global maintainer. So yeah, that was kind of problematic. And so we need to split the upstream batches in a way so we don't send 200 patches at the same time in order for people to be able to review them. And so we don't want to move that burden on our contributors, because there's a lot of different expectation within GCC, between the upstream GCC and our repository. There are some people that actively collaborate and work on GCRS that are very young and just plainly cannot use mailing list and such things. So to be fair, some people on their first pull request could not even do a proper rebase. So yeah, very inexperienced contributors sometimes, and we couldn't just tell them, yeah, let's just set up some git send mail thing with your Gmail account, go over the 30 options required for Gmail just because Google has decided it would be annoying with git send mail, and yeah, that wouldn't work. We would lose most of our contributors. It wouldn't work. So we found a new solution. GCC is currently experimenting with Forge based on Forgero. You may have heard about them. Their talk is live right now. Hopefully, you'll watch their recording of their talk. And they brought some very interesting changes. Basically, they introduced a bot that sends the patches upstream. And then upstream, a maintainer reviews the patches, ask about changes or whatever, and then we'll merge it. And we decided to do almost the same thing within our own repository. So we said that we don't want to commit upstream with every pull request, and we can, but it means we can still send the patches upstream for review when a pull request is merged. So we introduced a new GitHub action with a script that automatically sends an email upstream, and every time a pull request will be merged, a patch will be sent upstream with the content of the pull request. This means that every changes from an accepted pull request downstream will be able to be reviewed by anyone upstream, and the changes will be in the same patch list. So it will be easier for everyone, and it will keep the amount of simultaneous patches very low. I mean, pull requests have at most, let's say, 10 commits. It will be a lot easier, at least a lot easier than 200 commits. So yeah, as I said, it is a simple and easy bash script on a GitHub action. It is not live yet because we are still testing with it, and no command or interaction is required from a contributor. Our contributor just have to use the usual process to submit changes to GCRS. And the upstream folks will get nice and clean feature-focused batches with only a few commits that they will be able to review easily. Yeah.
You say that no interaction or action is required from the contributor. But if you're sending these patches upstream, it's to get review, right?
Yeah.
So what happens when there are review comments on these patches? What then does the contributor do if no interaction is asked of them?
Yeah. So we've not really discussed about that, but we expect people. I mean, there will be the address, the email address of the contributor within the CC list. So when the, let's say, a maintainer upstream reply to some changes, to some patch, it will be able to tell whether some changes are bad or should be changed, and the contributor will receive the answer with, in its email, in its mailing box. So I will be able to make another PR that will trigger another patch set. Okay. Let's get a bit a bit wild. There's some question that many people have asked me at this one. Will we switch to Forge? So I'd like to directly address those questions because I deem them important, and I'd like people to stop asking me. So the Forge project is a great idea, and basically, if some people here doesn't know it basically allows people to make submission from bots within web interface, and it simplifies greatly the submission process. Yes, and something that is great also, it's everything is discovery variable, from the front page. I mean, you've got to click on the issue link and you're redirected to the Bugzilla and the wiki too. And it is a lot closer to what most people are using nowadays. And hopefully it will bring some youngsters to GCC. And yes, as I said, it is 4.0, which is free and which is way better than GitHub, which is proprietary and awful. Yeah, go help them if you want GCC to succeed in the long run. I really think it'll help. But there's always a catch. The Forge is still an experiment, so we can't do anything right now. I mean, it could be removed at any time. Second thing, we'll probably need a vote from our contributors. One of the points that has been brought is that we would lose some of our contributors. All a bit hard. Some people just don't want to move, just don't want to change. And there's another problem is that some contributors are opting in and off every year. We are seeing them like for 2 weeks every year, right before Christmas, or let's say, thing like this. And we may just lose them. I mean, let's say you contribute for 2 weeks in 2024, you just disappear for a whole year, and then you come in the next year with a few IDs for your favorite restaurant end, and you just discover that the repository has been archived and that nobody is there anymore, nothing is smooth as you know it. So yeah, we may lose some. And also, some may dislike the new processes. So some people told that, and I'm part of those people, that it may cause friction with contributors. As I said, some of our contributors are very inexperienced, and I fear a little that seeing how to say. I mean, let's consider the Forge is working and has been working for a few years, okay? And everyone in GCC is working using exclusively the Forge. What will happen? There will be a lot of pull requests, there will be a lot of issues, and there will be a lot of people. And I fear that some inexperienced contributor might get a bit overwhelmed by this whole ecosystem. And yeah. Another problem, we would lose most of our meta information. So we decided a few years ago that we would use GitHub issues, and we decided to use GitHub PRs, and by changing to Reforge, we would surely have to find a way to transfer all those to the new system. And another point that has been made is that we would surely lose some visibility. GitHub sometimes act more like a social network, and some people like that. And to be fair, not many people from GCC community, but yeah, some of our contributors within GitHub like that aspect of GitHub, and while it is not shared by most GCC contributors, it is a point to take into account. Last point, the cross-references with the Rust Lang repository. We initially chose GitHub because it would be easy to reference an issue from another repository over GitHub. So let's say the Rust Lang repository. Let's say we've hit some problems, some bugs that has been fixed within Rust-C for a long time. We could just reference that issue easily, and those cross-references wouldn't work as well with the Forge. So no switch expected in the short, medium term, but well, only time will tell. And we're very enthusiastic about this new experiment because we expect a lot of people that weren't able to contribute with to GCC before, to be able now to contribute using the Forge. Okay. Have you got any questions or anything?
Can you give any kind of indication about the size of the GCC RS community at this point? How many contributors you have and how that might be changing?
Yeah. So there's a slight problem with that question. Is that it varies widely. I mean, as I said earlier, there's some contributors that are popping in like once a year. So should we count them or not? And so there is around, let's say, so there's 2 engineers working on it, and there's 1 guy working very regularly on it. And the more you go, I'd say. And from that point, there's a lot of other contributors, but they're not as close as the core members of the project. So you've got like, let's say, at most 10 people in the core team that are working regularly on the project, and you've got, let's say, around 15 to 20 regular contributors that are a little bit, that are working a little bit more irregularly on a project. Yeah. Okay, 22. I expect it to be a lot quicker than that, and usually people around me have a lot more to say about Rust than me. So if you want to say something about the project or anything, you could organize some kind of micro buff for 10 minutes. Nobody? Everyone wanna just eat lunch? That's right? Okay. Well then, thank you.